flux, it cannot able to rotate the rotor. I need additional flux or rotating magnetic flux. Then only it will be able to rotate. So I need another flux. It may be a leading. It will be look like a rotating magnetic field. So I need an additional winding in order to get a rotating magnetic field. That's why I have added an additional winding with respect to my stator. So that's why I have added a capacitor in the fan, because a single flux cannot able to rotate the rotor. So I need rotating magnetic flux. In order that I have added an additional winding or additional component together. So that's why in AC single phase AC induction motor, permanently they have connected a capacitor here, because the capacitor will produce the 90-degree leading power factor. So what will happen with respect to the main field winding? The capacitor will produce the another flux. It will be look like a rotating magnetic field. This rotating magnetic field can able to rotate the rotor. So then my rotor will be rotating. The rotating magnetic flux and then rotor will get mingle each other. So the output torque will be produced. So if I am giving anything without any additional winding, my single phase induction motor is not self-starting. If you are removing the capacitor in your fan, it won't run, because by single supply it cannot able to rotate the rotor. So that's why I have added an additional winding. The additional winding may be inductor or capacitor, whatever may be, but I need an additional winding. So the additional winding will produce the another flux. The another flux will be in the 90-degree lagging or leading. If it is 90-degree in phase, you cannot able to rotate. So that's why I have added a capacitor and inductor, because the capacitor in nature, V and I is always leads by 90-degree, and then in inductor, voltage and current is always lags by 90-degree. So that's why I have added a capacitor or inductor with respect to the main winding. So without additional winding, the induction motor is never starts. The single phase induction motor is not self-starting. With the help of the additional winding only, it can able to start. Is it clear? Is it clear or not?
Yes, ma'am.
Yes? If you have any doubt, please refer your fans. There you have seen the capacitor, cylindrical type round down and the help it will be running, because it produces the another flux. So it will be in rotating magnetic flux, then only it will be able to rotate the rotor. So if the rotor, once it rotated, what will happen? Producing flux, and then it will be interact with the main flux, it will produce the output torque. Yes? Is it clear? Is it clear or not?
Once more, ma'am.
Okay, I'm repeating once again. This is my main field, main winding is nothing but stator winding. And then this is my rotor. So I'm giving supply plus minus, it is AC, so it will be phase neutral. I'm giving supply to the stator winding. We know that by the mutual inductance only rotor gets supply from the stator winding. So if it is single phase, my flux will be in purely is singular in nature, but we need a rotating magnetic field. So then only it will be able to rotate the rotor. So I can add the additional winding. So I have added the additional winding with respect to the main field winding. This is my auxiliary winding or additional winding. So what will happen? I have connected 90 degree. Normally, I have connected opposite or parallel with respect to the main winding. Then only the interaction of flux will be in 90 degree. So if it is capacitor, we know that, we all know that, I don't know exactly. Normally, we have uses the three types: resistor, inductor, and capacitor. This is the play a vital role in the electrical part. Inductance, resistance always V is in phase with respect to voltage. So V and I are in phase, but in inductor V is lags by 90 degree with respect to I. The same way V leads I by 90 degree. So if you draw the capacitor voltage and current equation, my voltage is always leads by 90 degree. It will be leading. If you draw this, you can get the 90 degree phase shift with look like this. But in resistor, the voltage is always followed by current. There is no phase difference between the in resistance load. But in capacitor and inductor, V and I always 90 degree lags. And then it is capacitor V and I, it is leads by 90 degree. That's why I have connected the additional winding with respect to resistor without resistor. Resistors means I have get the same flux. If the main field winding will be look like this, if I connected the resistor here, what will happen? I have get the additional winding, it will be like this. It is not rotating magnetic field. So that's why I have added a inductor or capacitor. So if I am adding a inductor or capacitor, what will happen? It will produce the another flux with respect to 90 degree leads or 90 degree lags. So if it is leading 90 degree, it will be look like this. So it is leading 90 degree leading. So my graph will be followed by 90 degree. It will look like a rotating magnetic field. So this rotating magnetic field will get able to rotate the rotor. That's why I have added an additional winding with respect to the main field winding. Without additional winding, the induction single phase induction motor will never runs. It is not self-starting. So with the help of the additional winding, it can able to rotate the rotor. So then only it started to rotating. Was it clear? Is it clear or not? Yes? Somebody unmute and say, have you all understood the concept of why induction motor is not self-starting at all? Yes? I hope so. Then depends upon that additional winding. Which components I am going to use with respect to the additional winding? It will be classified into 4 types. The first one is split phase induction motor, capacitor start induction motor, and capacitor start run induction motor, and then shaded pole induction motor. So which component I am going to use here? Depends upon the additional winding. It is classified into 4 types. So first, the another type of induction motor is rotating transformer. Why it is called rotating transformer means because here the principle of operation is same as transformer, because both will be get supply from the mutual inductance. So it is called rotating transformer. And normally the transformer will not rotate, it is a stationary, but here my induction motor is rotating, that's why it is called rotating transformer. So the another name of induction motor is rotating transformer, the another one is asynchronous motor. Which is why it is asynchronous motor? It never runs at 1500 RPM. So that's why it is called asynchronous motor. The another name of induction motor is rotating transformer. Why? Because it will be work on the same principle of transformer. The transformer principle is mutual inductance, because the transformer has 2 winding, primary and secondary winding. We are giving supply only the primary, by the mutual inductance only. The secondary it gets supply from the primary. The same principle I am applying for the induction motor also. I am giving supply only with respect to stator. By the mutual inductance, the rotor will get supply from the stator. So it is runs on the transformer principle. So that's why it is called rotating transformer. Have you all understood the basic concept? Why it is not self-starting and all? Have you all? Have you all? If you're okay, then only I can move to the types of induction motor. Okay? And then have you all copied this? Have you all copied the diagram? Yes?
1 minute, ma'am. 1 minute, ma'am.
Okay. You all can copy the diagrams. While placing itself, the main field winding and auxiliary field winding are 90 we are keeping the 90-degree displacement with respect to main winding and then additional winding. Normally we have to keep like this only. Have you all submitted the assignment? I have checked only the 10 members are submitted. What about others? The deadline is tomorrow. If you not submit the assignment within tomorrow, and then I can mark it as 0.
I'm finished, ma'am.
Got it?
Finished, ma'am.
Okay. And then types of single phase induction motor. I'm repeating once again. That depends upon the additional winding. It is classified into 4 types. The first one is split phase induction motor. I'm writing as IM as I is nothing but induction motor. And the second one, capacitor start induction machine. And the third one, capacitor start, capacitor run induction motor. Last one is standard full induction motor. Copy one by one, and then I'm going to talk about the split phase induction motor. This part is visible. This side is visible.
Visible, ma'am.
Okay. This is my split phase induction motor diagram. I think it's visible. It is main winding. The last one is centrifugal switch. And then this is my auxiliary winding. I'm giving supply. In some textbooks, they have given the additional resistance for both main winding and then additional winding. No need to draw that. But they have given the resistance here also. In all the cases, I have connected the resistance because if it is why I have connected resistance means it limits the flow of current. So that's why in all the circuits we have connected the resistance here because it limits the current. Without resistor, we cannot make any circuit. So, normally the resistance purpose is to limit the flow of current. That's why they have given the resistance in the main winding as well as auxiliary winding, but no need to draw that. We have to know the concept of main winding and then auxiliary winding. Here, auxiliary winding, I have connected with the inductor. Inductor part. Why means inductor is 90-degree lags with respect to current. So it is 90 degrees lags means it is depends upon the main field winding. Main field winding lags 90 degree with respect to auxiliary winding. So what will happen if the both fluxes will be 90 degree displacement? It looks like a rotating magnetic field. If it is rotating magnetic field, my rotor will get able to rotate, and then the interaction of the main flux and then rotor flux will produce the speed torque. That is the concept. Have drawn here. Have drawn the phasor diagram of the split phase induction motor. So this is my phasor diagram of the split phase induction motor. We know that it is 90 degree lags because I have connected the inductor respect to the auxiliary winding. We know that inductor is always lags by B and I is always lags by 90 degree. So my graph with respect to I it will be lags. So if it is lag, my graph will be in the downside. If it is upper, my graph will be in the upper side. It is leading part. This is my lagging part. So I have connected the inductor as auxiliary winding. It is 90 degree lags with respect to the main field winding. So this is my starter winding, the stator flux, and then this is my rotor flux. It will be look like a rotating magnetic field. If you draw this, the graph will be, it is 90 degree lags, so it will be started to look like this. And redraw once again, then only you can easily understand. This is my main field winding. If I connected the inductor is additional, we know that inductor is 90 degree lags. So lagging means it will be started to come look like this. So it will be look like a rotating magnetic field. Please note it down. RMF is nothing but rotating magnetic field. So if it will be looking, it will be producing rotating magnetic field, then only the rotor can able to rotate. So that's why I have added an additional winding with respect to the inductor. So the split phase induction motor, the additional winding is inductor. So the graph will be lagging in nature because 90 degree lags. So the graph will be in the downside. If it is downside means it is lagging part. If it is leading, the graph will be in the upper side. So it will be this is the current I have get reflux will be get in terms of the diagram, phasor diagram. So what will happen? I'm getting a additional winding, additional flux with respect to 90 degree, and then what will happen? The main field flux we can able to rotate the rotor gets applied, the rotor will produce the rotating magnetic field, rotor flux, and then the main flux and the rotor field flux will be adding together, and then it will produce the output torque. So what will happen? My motor will start to running. Once it reaches the 90% of the synchronous speed, 90% of the rated speed, what will happen? My centrifugal switch is automatically open, which means my auxiliary winding will be only used for the starting purpose. I'm repeating once again. Once it will be all set up, the main field flux will be rotating with respect to rotor, the motor will be rotating. Once my motor will attain a 90% of the rated speed. So once it reaches that 90% of the rated speed, what will happen? My centrifugal switch automatically open it. What will happen? If it is open, my auxiliary winding will be open, which means I can use for the auxiliary winding on the starting of the induction motor. Is it clear? Is it clear?
Yes, ma'am. Yes, ma'am.
So it will be open means, and my auxiliary winding will be open. So no need to worry about. Already the machine will be started to working. There is no need of rotating magnetic field. If it is started to working, no need to bother about the additional winding and all. So once it reaches the 90% of the rated speed, automatically my centrifugal switch open. It will be cut off the auxiliary winding from the main winding. So it will be only used for the starting purpose. Is it clear? So it is only used for the starting purpose of the rotating the induction motor. Yes? Is it clear? Any doubt in it? Any doubt? The working principle of how it works, then what is the need of centrifugal switch, and then why it is removed, and have you all understood?
Yes, ma'am.
Shall I erase this? And then please note it down where the split phase induction motor can be applied. The first one is we can apply for fans, blowers, and then washing machine. So there you can use the split phase induction motor. The main thing here, what will happen? You have to note it down the power factor and then starting torque depends upon the split phase induction motor. So why means we have to need a high starting torque. If it is high starting torque, then only the induction motor will run at a high speed. I'm repeating once again. I didn't talk about the high starting torque in terms of DC motor because normally it is self-starting that no need to worry about the starting torque and all. But here it is not self-starting. With the help of the additional winding only I have started. So we have to get the high starting torque. Then only the machine will be run at the high speed. So but in split phase induction motor, the starting torque is about 100% or 250% of the rated value. Please note it down. This is the thing you have to know that the characteristics of the split phase induction motor. I'm repeating once again. Here all the motors characteristics wise will be differing. So we have to know which percentage the high starting torque and then power factor will be varying. Depends upon the split phase and capacitor start and capacitor run induction motor. And then it is breakdown torque about the breakdown torque up to 300 Newton meter, and the next one is power factor is 0.5 and then 0.65 and then the last one, the efficiency will be 55% up to 65%. These are the things you have to know while ending with the split phase induction motor. Repeating once again. Here the rated torque about 100 to 50% of the rated value and then breakdown torque up to 300 and then power factor is 0.5 to 0.65 and then efficiency about 55% to 65%. Yes? Please note it down.
Just the last assignment is the heating and cooling curve. So you are given in last class. This is the non-term. So you want to submit the heating and cooling curve assignment. But you want to upload it either in the PDF form or in the image form. Okay? Link is open now also, but we will close by the end of the day. So, minimum number of students have submitted the assignment. Remaining students want to submit it today. Okay? It is clear on this.
Ma'am.
Yes.
Ma'am, அந்த ரேட்டிங் வேல்யூ எதை பேஸ் பண்ணி மேம் போடுவாங்க? மேம் கேரக்டரிஸ்டிக்ஸ்ல ரேட்டிங் வேல்யூன்னு போட்டிருக்கீங்களா மேம்?
Yes.
அது எதை பேஸ் பண்ணி மேம் எடுப்பாங்க?
Already once எப்படி சொல்றது இது ரன் பண்ணி அதோட எஃபிஷியன்சி என்னன்னு டெஸ்ட் பண்ணி தான் சொல்லுவாங்க. அப்படி சொல்லும்போது அதோட எஃபிஷியன்சி இந்த மாதிரி இருக்குன்னு ஆல்ரெடி டெஸ்ட் பண்ணி புக்ல எழுதிருப்பாங்க. அதுதான் சொல்லிருக்கேன். Characteristics. See, while testing or while writing the characteristics, before that they have to run the machine and then they have to do the reading. Then only they can say that the efficiency will be 55 and 65% and all. If you are trying the experiment in the split phase induction motor, you can get the values. So this is the torque efficiency characteristics. Already said it is about the 100 or 250% of the rated torque. So up to this, the main winding and the auxiliary winding will be working. The once it reaches the 70%, 75% of the rated speed value, the centrifugal switch will be open. After that, it will become the EV works depends upon the main field winding.
Please, while doing the experiments, you will get the clear idea about what we got done. It is nothing but the characteristics and efficiency. So you will get a clear idea about it. So in last class, we have written experiment. It is speed control. So we didn't plot the graph for efficiency and all. So while we doing the next experiments, so you will get a clear about the efficiency, torque, speed. Like that. Okay. By Tuesday, we will do the experiment. Here, so you will get a clear idea about it.
Last class, I have talked about the characteristics. How I said torque is directly proportional to Ia. If you are doing the experiment in the lab, so you can get the same graph. So that's the same will apply for the induction motor. So if you are doing the experiment with respect to split phase induction motor, the torque with respect to speed graph will be looked like this. So up to this, you can use that the starting purpose. I can connect the both main winding and the auxiliary winding. what will happen once it reaches that 75% of the rated speed, my centrifugal switch will be open. After that, the main field winding will only give the supply to the rotor. So that's why, what is that meaning? Only we have used for the auxiliary winding for the starting purpose. These values are already, they have run the motor, then they have put the values they have given in the textbook. All the things, the last class I have told about the characters, how it's varying, it all they have run and then they have written in the book. If you are all doing the experiment, you can get the same value. If you run the machine, what is my efficiency? Efficiency is nothing but output by input. If you are run the machine, you can get the values up to 55 to 65% efficiency. Yes? Any doubt? Any doubt in split phase induction motor? Please note it down.
These are important topics, so please make note of it.
Yes?
சார் உங்க வாய்ஸ் எக்கோ அடிக்குது சார் நீங்க பேசல.
Is it clear the split phase induction motor? Shall I move to the capacitor start induction motor? Now somebody unmute and say, shall I move to the next type, capacitor start induction motor?
Yes, ma'am.
The same diagram, the split phase induction motor, instead of auxiliary winding inductor, I can remove the inductor, I can place the capacitor, that is called capacitor start induction motor. I'm repeating once again, the last circuit diagram, I have connected the auxiliary winding with respect to inductor. If I remove the inductor, and then I can place the capacitor, that is called capacitor start induction motor. The same working principle will apply for the capacitor start induction motor also. So what is that? Capacitor, and then centrifugal switch, and then it's my rotor. Am I correct? The last split phase induction motor, I have added the additional winding with respect to inductor, but here I have connected the capacitor because it is called capacitor start induction motor. So instead of capacitor, I can place the capacitor here. Again, it is main field winding. Then this is my auxiliary winding or additional winding, and then this is my centrifugal switch, and then this is my rotor. The same diagram, only one item I have rearranged. Instead of inductor, I have placed a capacitor. That's why it is called capacitor start induction motor. If I connected a capacitor, the induction motor is capacitor start induction motor. The same procedure, what will happen? The main field winding is connected with capacitor. So capacitor is always 90-degree leads by nature. So what will happen? It will produce the rotating magnetic field. So with the rotating magnetic field, we can able to rotate the rotor. So rotor will start rotating. The rotor will get flux, get supply, and it will produce the flux. And then interaction of the main field flux and then rotor flux will produce the output torque. So once it started to rotating, once it reaches the 75% of the rated speed, what will happen? My centrifugal switch will be automatically open. What will happen? The capacitor will be disconnected from the main field winding. So again, it will be used for only the starting purpose. The same principle, same working principle as split phase induction motor. Instead of inductor, I have placed a capacitor, nothing else. Again, once it reaches the 75% of the rated speed, automatically the central switch opens and then the capacitor is disconnected from the main field winding. So again, it will be only used for the starting purpose. Was it clear? The capacitor start induction motor, is it clear? Is it clear or not?
Once more, ma'am.
Split phase induction motor புரிஞ்சா உங்களுக்கு? The one
Yes,
link
ma'am.
between the split phase and capacitor. Here I have placed the inductor, means it is called split phase induction motor. If I remove the inductor and then I place the capacitor, it is called capacitor start induction motor. So what will happen? Why I have connected the additional winding? Because the single flex cannot able to rotate the rotor. We need rotating magnetic field, so I need additional winding. The additional winding may be inductor or capacitor, because the inductor and capacitors will produce the lagging and leading flux. That's why I have added an additional winding with respect to inductor and capacitor. The last case I have connected the inductor, but in this case I have connected the capacitor. So what will happen? It will produce the 90-degree flux with respect to main field winding. So it will produce the rotating magnetic flux, and then this rotating magnetic flux will be able to rotate the rotor. Rotor gets applied, and then rotor will produce the rotor flux, and then it will be interact with the main flux. The output torque will be produced once the rotor is rotating. Once the motor is started to run, what will happen? Once it reaches the 75% of the rated speed, the centrifugal switch automatically opens. It will be disconnected from the main supply. It will be open this part, which means other things, another part, what will happen? After that, it will be working with the help of the main field winding. So I can use this setup for only the starting the induction motor. That's why it is called capacitor start induction motor. It is only used for that starting purpose. That's why it's called capacitor start induction motor. Is it clear now?
Okay, ma'am.
Yes? So again, I have to draw the phasor diagram as well as the torque versus speed curve. So what will happen? It is 90 degree. So the graph will become downside or upper side. Answer my question. Answer my question. The graph will be look like this. How it will be look? It is inductor. So my starting flux will become like this because the main field winding is inductor. Do you know that? It is resistor, this is my inductor, and then this is my capacitor. So the main field winding is inductor. It is 90 degree lags. So I have drawn the current or flux in terms of lagging. Again, it will be 90 degree leading. So capacitor is always 90 degree leads. The graph will be comes like this. So compared to previous one, it produces the large phase difference. If it produces the large phase difference, it will be produce the high starting torque. So compared to split phase induction motor, my capacitor start induction motor will produces the high starting torque. If it is high starting torque, this machine or this motor will run at a high speed compared to split phase induction motor. In split phase induction motor, I have connected the inductor 90 degree with respect to inductor, but here I have connected the capacitor. So the inductor is 90 degree lags and the capacitor is 90 degree leads. So the phase difference between the whole setup will be very high. If the phase difference is high, it will be produce the high starting torque. But in the last case, the graph will be look like this because both are in lagging in nature. It will be less phase difference. So if it is less phase difference, we cannot get the high starting torque. So the capacitor start induction motor will produce the high starting torque. So it can run at a high speed instead of split phase induction motor. It can be used for the high speed applications. Is it clear? Is it clear or not? Is it clear? Sir.
Is it clear? We are having another one type of motor.
Is it clear? Capacitor start induction motor. Is it clear or not? The last one is torque speed characteristics. It is torque. So up to this, the combination of main and auxiliary winding will be running. So this centrifugal switch will be open here. So it will be run on the main field winding. So this is my speed. This is my torque. So the torque will be 100 or 200. It will be very high. So the starting torque is about 350 or 500. This is my 75. And then this is my 100. The same 25 and 50. Is it clear? Is it clear or not?
Yes, ma'am.
Yes?
Yes, ma'am.
No? Shall I erase this? Have you all
Yes, ma'am.
copied?
Yes, ma'am.
The next one is capacitor start, capacitor run induction motor. So in this diagram, I can remove the only one thing, then it will be start, capacitor run induction motor. Do you think which I can remove this from this diagram? I'm repeating once again. The next one is capacitor start, capacitor run induction motor. So for this, the same diagram I'm going to apply, but I have to remove the one component from this diagram. Do you think which I can going to remove? See the name, the types, the capacitor start, capacitor run induction motor. Then you say which I'm going to remove from this diagram. Any guess, please? Any guess?
Ma'am, main winding remove பண்ணுவோம் ma'am.
Main winding. Then how you can get the rotating magnetic flux?
Ma'am, capacitor வச்சு தானே ரன் பண்றோம்.
We need two flux. So that's why I have added the additional winding. Is it clear? You cannot remove the main winding and then capacitor winding. The name is capacitor start, capacitor run induction motor. The last type we have used for the only starting purpose. That's why it's named as capacitor start induction motor. But the name is capacitor start, capacitor run induction motor. So I can remove my centrifugal switch, which means the capacitor will be run for the running time also. Once you off, remove பண்ண முடியாது. It will be set as it is. So that's why it is called capacitor start, capacitor run induction motor. If it will be produced keep on the phase difference high, so it will be producing the high starting torque. But in the last step, what will happen? Once it reaches the 70% of the rated speed, the centrifugal switch will automatically open. It will be removed from the main field winding, but it will be there in the running time. It continuously produces the 90-degree phase shift, which means throughout the condition, it will produce the high starting torque. So that's why I have kept the capacitor for the running time also. That's why we have used in the fan this capacitor start, capacitor run induction motor. Is it clear? Is it clear? Is my voice audible?
Yes, ma'am.
Have you all understood what I'm trying to say in the capacitor start, capacitor run induction motor? Have you all understood? Have you all understood or not? So why I am moving to the capacitor start and capacitor run induction motor instead of capacitor start induction motor? Why? Why? Now somebody unmute and say why I have moving to the capacitor start and capacitor run motor.
Capacitor start motorல வந்து 75% மேல வந்து ஃப்ளெக்ஸ் போயிடுச்சுன்னா ஆட்டோமேட்டிக்கா சென்ட்ரிஃபியூகல் ஃபியூஸ் வந்து ஆஃப் ஆயிடும் மேம். கெப்பாசிட்டர் ரன் மோட்டர்ல வந்து நமக்கு ஃபுல்லாவே டார்க் தேவைப்படுறதுனால ஃபுல்லாவே ரன் ஆகும் மேம்.
That is not you are saying somewhat okay. I appreciate that, but the thing is, if you open this, we cannot get the high phase difference. We can get only the starting time. We can get the high starting time because the starting time only the capacitor is available. Are you agree that? So normally we have connected the capacitor with respect to centrifugal switch. Once it reaches the 75% of the rated speed, it will be automatically open, which means it will be disconnected from the main field winding. Which means it will give the phase difference only for the starting purpose. So starting purpose means only they are get the high starting time for the particular period. After that it will be removed. So we are getting the less amount of high starting time. For particular time only we are getting the high starting time. If I remove the centrifugal switch means I keep on the running period also I will get the same phase difference. So instead of using the capacitor start induction motor, I can use the capacitor start capacitor run induction motor. The phase difference is clear. It will be always in the large for the running time also. It will be produces these high starting torque from the starting to ending. So instead of using the capacitor start induction motor, I can move the capacitor start capacitor run induction motor. Is it clear? That's why we have all used this type of motor for if you see the fans and then what is that? We have seen the induction motor normally. There the capacitor is fixed in nature. So that type is capacitor start, capacitor run induction motor. For the running time also the capacitor is present in that for producing the high starting for large phase difference. If the phase difference is large, it produces the high starting torque. If it is high starting torque, it will be run for the high speed application. So that's why we have moved for the capacitor start, capacitor run induction motor. Compared to 3 split phase and capacitor start induction motor, the capacitor start and capacitor run induction motor is high starting torque throughout the running condition. Is it clear? Is it clear? Is it clear or not? Is it clear? Somebody unmute and say. Okay. So this is the capacitor types. The last one is shaded pole induction motor. For till now, any doubt? I think so. I hope so. So I am moving to the last type is shaded pole induction motor. It is bit different than the other things. So we won't join the additional winding. Instead of joining the additional winding, I have connected the shaded pole here. So once I draw the circuit diagram, you can able to understand how it will be varied. Yes, the last one is split phase induction motor. Before that, we didn't write the speed torque, how it will be starting torque and efficiency and all. Please note it down. The capacitor start induction motor torque speed curve, this is diagram, and then the starting torque and then efficiency. And then I have gone to the next one. This is the torque. and then it's the percentage of synchronous speed. It is high starting torque, then it is high efficiency, then high power factor. Please note it down. Then the characteristics. Please note it down the characteristics of capacitor start and capacitor run induction motor. The starting torque, it will be 20% or 200% or 300% with rated torque, and then breakdown torque is up to 50%, and then power factor is 0.75 to 0.9, and then efficiency is 60 to 70%. So the diagram will be differing upon the text to text. In some textbooks, they have given their diagram will be with respect to resistance and the addition of another capacitor. But this is enough. If you know the concept, you can draw your own diagram. Any doubt in it? If you copy it, let me know, then only I can erase and then I can draw the last type split phase induction motor. Have you all copied? Have you? Last one is shaded pole induction motor. Yes. The last one is shaded pole induction motor. This differ from the three types. Here, instead of connecting the additional winding, I have connected a shading coil here. With respect to the shading coil, I can get the rotating magnetic field. Here, I'm giving supply to the stator winding. So what will happen? It will followed by the shading coil also. Depends upon the flux range, it will be producing the rotating magnetic field. If you go deeper, it will be classified into T1 and T2, T3. How it will be varying? In some cases, this is my shading coil. If flux will be produced only this part, it will be start increasing. If this flux will be produced, depends upon the central part, it keep on increasing. So it depends upon the deviation, it will produce the another flux. So no need to go this and all. We just know the concept because you are a mechanical student, so no need to worry about that T1 and T2 and T3 part. But in some textbooks, they have given clearly how the flux will be induced. It depends upon the T1 period, time period, T1 and T2 and T3. So once the flux will be entered, depends upon the time period. But flux will be keep on producing. If the flux will be entered exactly to the respect to the shading coil, it will produce the high flux. And then what will happen? It will be decreasing, so it will be started to decreasing. So it will produce the another flux. With respect to the main flux, what will happen? It will produce the rotating magnetic flux, and then after that the rotor will get rotated, and then the motor will start to rotating. But compared to three things, it will produce the less starting torque. The motor 40 or 40% to 60% of the rated torque. So it is used for the low power application because it is starting torque up to 40 or 60%. So think that the last class, last capacitor start induction motor is about 300 or 250% of the rated torque. So compared to before that, it will be very less. So it is used for only the low power application. I'm repeating once again. Here I have connected the shading coil, the black coil. So what will happen if I am giving the supply? The production of flux, the amount of current will be entered to the shading coil. It will be varying. It will be depends upon the how it will be occurring for the particular period and the central period and the last period. The production, the EMF will be flux will be induced here. Depends upon the shading coil. So what will happen if it will be passed to the first part and second part, third part, it will produce as the another flux. It will be intact with the main flux. What will happen if my main flux and then induced flux will be in 90 degree or 60 degree phase shift. So what will happen? It will produce the rotating magnetic flux, and then this rotating magnetic flux will move to the rotor. Rotor will get supply. Rotor will produce the rotor flux. It will induce with the main flux and the rotor flux. The torque will be induced. That is the concept of shaded pole induction motor. Have you all understood a little bit? I think so. I didn't talk much about the time period. If I am going to the deeper means I need one class to talk about how the current will be occurring T1 part and T2 part and T3 part. They have given the three cases. If you have opened any textbook for shaded pole induction motor, they have given detail about how the current will be varied from T1 and T2 and T3. No need to worry about. You should understand. It will be depends upon the time period. The flux will be varied. That's enough. So compared every time it will be produced the less starting torque because it is started about it is for 20 or 40 percentage. So it will produce the less torque speed characteristics. So it is used for only the low power application. So it is about 40 or 60 percentage of the starting torque. So again, the phase difference between a main field and then auxiliary field will be less. So it will be again a low starting torque machine. So normally this type of machine we are used to for the only the low power application. Then normally we have the capacitor start, capacitor run, induction motor only. But you should know what are other types is there. That's why I have thought about the throttle pole induction motor. Have you all understood? Have you?
Example.
Example, it can be used for hair dryer, motion picture projector. So it is used for the low power, low speed application. Hair dryer, there we can use the standard pole injection motor. Are you satisfied? Have you all understood what is meant by started pole? Why it is low starting torque and then where it is used? From the hair dryer itself, you can know it that it is used for the less speed application, low speed application only. Is it okay? All of you? Somebody unmute and say, or you can say in the chat box also. Have you all understood? Okay? So we can discuss about the next topic in the next class. From this, the first half of the module 2 will be over. The next topic is 3-phase induction motor. Probably I will teach on Monday. Thank you all of you. Please submit assignment by tomorrow.
Yes, you want to submit an assignment by the end of the day.
மேம் கூகுள் ஃபார்ம்ல சப்மிட் பண்ணா போதும்ல மேம்? கூகுள் ஃபார்ம்ல அசைன்மென்ட் சப்மிட் பண்ணா போதும்ல மேம்?
கூகுள் கிளாஸ்ரூம்ல கொண்டு போய்.
ஓகே மேம்.
மேம் அந்த ஹீட்டிங் அண்ட் கூலிங் தானே மேம்?
ஆமா, ஹீட்டிங் அண்ட் கூலிங் தான்.
ஓகே சார்.
ஓகே
சார், அந்த ஹீட்டிங் அண்ட் கூலிங் வந்து அன்னைக்கே கூகுள் ஃபார்ம்ல சப்மிட் பண்ணியாச்சு.
ஆமா ஆமாண்டா, எல்லாமே தான்டா, செக் பண்ணிக்கங்க, எல்லாமே ஓபனா தான் இருக்கு. திருப்பியும் சொல்ல, நீங்க சப்மிட் பண்ணிட்டா விட்டுருங்க, அவ்வளவுதான்.
சப்மிட் பண்ணா போதுங்களா? அப்லோட் பண்ணா போதுங்களா சார்?
அப்லோட் பண்ணா போதும். நிறைய பேர் சப்மிட் பண்ணாம இருக்கீங்க, அவங்களுக்கு தான் சொல்றோம்.
ஓகே
ஓகே சரி.
கூகுள் கிளாஸ் ரூம் சார்?
ஆமாடா, கூகுள் கிளாஸ் ரூம்ல தான்
சார். கிளாஸ் ரூம்ல அசைன்மெண்ட் எதுவும் போஸ்ட் பண்ணல சார். சும்மா பிடிஎஃப் மட்டும் அப்லோட் பண்ணி விடணுமா சார்?
சும்மா பிடிஎஃப் உங்க ரோல் நம்பர் போட்டு அப்லோட் பண்ணி விடுங்கப்பா.
சரி சார். ஓகே சார்.
சரி, थैंक यू பா.
சார்,
थैंक यू சார்.
थैंक यू டா. சொல்றா
சார். உடனே ஜாயின் பண்ணிட்டேன் சார். அதாவது எதுவும் பிரச்சனை வராதா சார்?
புரியல ராஜு.
சார்
புரியல.
இப்போ கட் ஆயிடுச்சு சார். கட் ஆன உடனே கேக்குதா சார்?
கேக்குது. ஓகே, நாங்க பாத்துக்கிறோம், ஒன்றும் பிரச்சனை இல்லை.
ஓகே சார். கட் ஆன உடனே நான் உடனே ஜாயின் ஆயிட்டேன் சார்.
ஓகே, நான் பாத்துக்கிறேன்.
எவனையும் பார்க்கணும். சார் நெக்ஸ்ட் கிளாஸ் எப்போ சார் ஸ்டார்ட் ஆகும்? சார்
Okay, sir.